In some cases, there are some word problems that you can actually solve using systems of equations. One type of this word problem is sort of a number comparison problem. So, for example, if I say one number is 2 more than 3 times another, and we know that their sum is 26, and I want you to find the numbers. So the first thing that we should do is label variables. Since we have two numbers that aren't related to each other, we should call x one of the numbers and then y the other number. Again, you can pick whatever letters you want to represent it. It's kind of like naming your dog, right? You can name it whatever you want and it's not going to change the fact that it's a dog. So the same thing with variables. You can call them whatever you want. So in this case, we're just going to let them be x and y, as usual. So now we have to decipher this information. So we know that their sum is equal to 26. So when we add both of the numbers together, we get 26. So x plus y is 26, right? And we also know that one number is 2 more than 3 times another. And this is probably one of the main problems that students have in mathematics, is translating this English into math. And as it turns out, you can sort of do a straight translation. So, for example, where is, we can write an equal sign, right? And this harks back to other different problems where we usually let is be equal, right? So now we know that one number, so what was our one number, x, is 2 more than 3 times another. So 3 times the other number, and then 2 more. So that is actually the straight mathematical translation of our sentence. So let's write that down as our second equation. So now we have two equations, and we don't have to look for any more equations. Well, mostly because there aren't any more sentences to translate, but also because we have two variables. So when we have two variables, we find two equations. If we had 3 variables, we would find 3 equations. So now we're done, and now we can solve the system. So considering that we have x in terms of y, we can use the substitution method. So we can substitute (3y plus 2) for x in the first equation. So basically, wherever you see an x, you replace it with 3y plus 2. So then we end up getting 3y plus 2 plus y is equal to 26. And now notice, there's only y's in this equation, so this becomes a linear equation in one variable, which we know how to solve. So simplifying, I'm just going to get rid of the parentheses here. 3y plus 2 plus y is 26. Combining the y's together, we get 4y plus 2 is 26. Subtracting 2 from both sides, we know that 4y is equal to 24. So y has to be 6. So great, we found our y, and now we get to find our x. And you can plug it into either equation. I'm going to plug it into the second equation, but plugging it into the first is just as good. So plug y equals 6 into x is equal to 3y plus 2. So we get that x is equal to 3 times 6 plus 2, which is 18, plus 2, which is otherwise known as 20. So now we can write our answer, since we found both x and y. And usually you write your answers in a whole sentence, a complete sentence. So you want to say the two numbers are 6 and 20. And if you feel so inclined, or if you have a little bit of time, you can always check. And how you check is by plugging in 6 and 20 and checking it in the original problem. So let's go back to the original problem. So let's just check up here. We're wondering if the sum of 6 and 20 is 26. So 6 plus 20 is 26. And this one checks out. What about the second one? Oh, sorry, the first problem. The first sentence, excuse me. One number is 2 more than 3 times another. So one number, what was our one number? It was x, which was 6, right? No, x was 20. So we want to check if 20 is 2 more than 3 times the other number. So 3 times 6 plus 2. And as it turns out, 3 times 6 is 18 plus 2 is 20. So this one checks out as well, which means that we did the problem correct and that this is our final solution. The two numbers are 6 and 20.